Hi, my name is Dave. Today we're going to talk about the interesting process of selecting or designing a custom wedge for a quantum 4 telescope. Is it this one? Or is it that one? Or maybe is it something else? This is a Meade 884 tripod. It's got a Meade ETX on it, which is what it was designed for. And at first I thought this might make a good solution to mount my quantum 4. This mount has a couple of 1/4 inch 20 bolts. And if you are clever enough to match that up, you can actually put this on there. It is a very insecure way to mount this telescope though. That's a heavy telescope. You don't want it hanging by this single 1/4 inch 20 bolt on this rather flimsy mount. So I thought I'd improve on this, and I built a special plate. Here's the plate I built. Let me mount this on there and show you what it looks like. Now I have the quantum 4 mounted on this Meade 884 tripod. A couple of things to notice about this. One, you can adjust for the latitude here very nicely, but there is no stop on this thing. If that thing decides to go, it's going to go, and it's going to take the whole tripod with it. So that is an extremely dangerous situation. There's also no way to aim this precisely north and south. This is not very precise either. So there's no good way to get a good precise polar alignment with this mount. So this was a problem. I decided I wanted to do something about this, and I replaced this with a bolt. So I now have this mounted with a much more secure system. Even if you loosen this, the nut down here will stop it from going too far. It's just a much more secure arrangement. But still, the balance gives me pause, because this thing, the center of gravity of this mount is right about there. So it's kind of way over this third leg, and this leg here, it kind of gets in the way. If you're trying to do some observing, you're walking around, you're going to trip over that thing anyway. So I don't much like this arrangement. And I thought maybe there's a better solution. Now I have the scope mounted on an old wedge for a C8. And this one is perfect. The slots fit beautifully. You can even still plug in the power plug with this. So everything is perfect. And in addition to that, you can polar align this. I'll show you how that would look. If you're going to polar align this scope, you're going to be back here. You're going to adjust as you can see it changing the tilt there, so you adjust for your latitude there. Up here in the front, you loosen these bolts, and then you can adjust it right and left. So you can polar align very precisely with this mount. There are only two minor difficulties with this mount. The first one is this. If I'm seated and I'm observing with this telescope, great. Scooch the chair in. Okay, everything's good. I'm near the ecliptic, so everything's going to be just fine. If I get off the ecliptic, though, over here somewhere, look at how far I have to lean in. It's not that bad. I'm exaggerating, but it's not as convenient as it could be. And the reason for that is the center of gravity for this mount and telescope combination is right about here. All right, let's see if we can determine where the center of gravity of this thing is. We're taking the whole system, including the wedge, everything else. You can see I've got this set at about 40 degrees or so. The center of gravity, it's not there. It's not there. It's right about there. So the center of gravity of this thing is right about there, at least with that latitude. I'm not sure if it'll change much if I change the latitude. Go that way, maybe an inch. All right, let's see how that changes things. Make sure it's balanced on the rod. And moves things a little bit. This wedge is designed for an 8-inch telescope, which comes out quite a bit further, and it's just about ideal. It puts an 8-inch right here, right where you want to be. It's perfectly balanced on the tripod. The Quantum 4 is just a little bit small. Although it fits, everything works, it's just a little bit small. And it looks a little awkward too, doesn't it? It looks a little funny. As a matter of fact, the aesthetics of this mount, although it's not bad, it's a telescope wedge, what the heck, looks okay. But I think I can do better than that. After considering all the design changes and requirements, I decided the only thing to do was to go ahead and make one for myself. So I went into my shop and I built this wedge here. As you can see, it's very similar to a Questar wedge that I built several years ago. It's based on the same basic design, but this one features the ability to micrometrically adjust for precise polar alignment. Let me demonstrate how this works a little bit. First of all, if you want to rotate this whole thing, it's very simple, so you can easily figure out where you want it. I really designed this so that you could be seated in a comfortable position, like over here, and not have these legs get in your way. Anyway, you can put this anywhere you want, and you tighten it down here. Notice you don't use this. This allows you to adjust the fine motions for the azimuth setting. So you don't use this. This is for that purpose. So we can switch this around here. Now back here you'll see at the business end we have a fairly standard kind of a wedge construction. Although it's unusual in the sense that this is not a complete 90 degree. The Questar was a full 90 degree fantail. This is what I call an offset fantail, in the sense that there's a partial fantail here and it's offset by about 30 degrees or so. And that allows you to go as far north and south as is pretty much practicable. You can go up to 15 degrees south latitude, up to about 65 degrees north latitude with this mount. And if you want to go further than that, you're going to have to use the legs to adjust it, and then offset from there. Okay, here are the maximum amounts of motion of this mount, this wedge. There's the furthest north, furthest south. I've loosened all these adjustment bolts up. It actually goes a little bit further than that. Anyway, so you can see now the maximum extent of the motion here. You can also see where it's controlled through these nuts here. Tighten those up, and that limits the amount of motion. Of course, you can lock it down here with those and those as well. That really gives you secure. Once it's set up, it's very, very secure. All right, so you can see how that's working. Here's the demonstration of how that actually works in practice. Let's put this someplace and just use these adjustment knobs to show you how it works. You loosen these up just a little bit, and then you move these back and forth. I should really do it with the telescope on there to show you that. Let me put the telescope on. Alright, to make this more realistic, we've now got the telescope on there, and now you can see what's happening here. I can only go so far because this thing is stopping it. So these are push-pull type deals. This one comes that way, or it goes that way. In this case, the telescope is trying to pull it down. So then you tighten it up. If you need to, of course, you can adjust it up a little bit, go back and forth with it, just like standard push-pull type bolts. And the same thing is true here with the azimuth. You've got one over here that pushes, and the other one pushes or relaxes. So I think you can see that that's moving. And when you set this up and do the polar alignment, you've actually got very, very good control. You can get really nice, precise polar alignment with this. One thing you may notice about this, for those of you who own Quantum 4s, you've got this power plug here. I think all Quantum 4s have a power plug in the same location. Mine does. I set this up so that it's got carved out areas, which is nice. It reduces some weight. Plus, the carved out areas allow you to have the plug, no matter which position you happen to select for mounting this, for putting the mount on the wedge. There's a slot there so that you can plug the telescope in, plug the clock drive in. Let me remove this from the semi-pier and show you what's going on. The semi-pier is actually part of this mechanical adjustment. If I take this off, you can see there are two notches here. And those two notches are where these two push bolts engage. Very simple, really. The two push bolts just push and pushes the top of the wedge around. Now, this is like many other modern mounts. You have to make sure that you know what you're doing when you put this on there so that those match up. Won't be any great harm if you don't. It surely won't work. So once you get that set up, and of course you want to give this some moderate tension, just a little bit of moderate tension, just so that you get good positive control with this thing. There are two possible places to mount this. I designed this so that if you're using it at a far south latitude, you may want to use one hole, and far north latitude, you may want to use the other. So there's two holes here, these two holes. Either one of those can go in here. But when you do that, these things are going to engage farther back, so you have to screw this all the way out here. Okay, I've now screwed these adjustment bolts to their all the way back, just about. And now I can use this rearward mounting hole. Make sure everything lines up right. Okay, looks good. Now these guys are okay, now they're engaging. So now you've got this set up for a, that would be for a more southern type latitude. Hope you've enjoyed this little look, and thank you for watching.